Welcome back into the next section, 03. In this section, we're going to review how to factor some basic polynomials. Now, you've heard about factoring before. I know for a fact that in Algebra 1 they covered that. However, you may have forgotten, and if so, you're not alone. Most students coming from Algebra 1 to Algebra 2, it slipped their mind how to factor. So I'm going to teach this just as if you were learning for the first time. And this section in particular has a lot of practice problems that we'll go through together. So hopefully by the time we're done with this section, you're refamiliarized, or maybe you're finally understanding for the first time how to factor. So let's get to it. Before we can actually start factoring polynomials, we have to know what a polynomial is. So a polynomial is a collection of terms. And I believe I've explained this in a previous section, but a term is something that's separated by a plus or minus sign. So if we have something like this, 4xy squared plus 3x minus 5, the 4xy squared is a term. Three x is a term. And I put the 5 as a term here. It's really -5. Negative goes with the 5. But I want to emphasize the point that terms are separated by plus or minus signs. So this polynomial has 3 terms. We would call that a trinomial because the prefix tri means 3. Triangle has 3 sides, tricycle has 3 wheels, trinomial has 3 terms. So we're going to be factoring trinomials and binomials. Binomials have 2 terms. So just a little vocabulary to get us started here. So if we want to factor, it's important to know what you should do at every step. And I feel like the hardest step in most math problems, especially for people who struggle quite a bit, is what to do at the beginning. You have a problem that says something like this, and you're like, I don't even know where to start, honestly. But with factoring, it's great because you always have the same first step. It's always the same. Step 1 is to always look for a greatest common factor, okay? Or GCF. We usually just take the acronym there. So if I say to look for a GCF, what I'm asking you is, for a particular polynomial, does every term have something we can factor out? Is there something we can pull out front that's common to every term? And let's see what I mean here. So for example 1, we're going to get straight into it here. We need to factor 3q squared minus 9q. Now before we start with step 1, let me just ask, how many terms does this polynomial have? It has 2 terms. 3q squared is a term, and the minus 9q is a term. So we've got 2 terms. This is a binomial. Now, let's look for a greatest common factor. What is the biggest thing we can pull out of both of these terms? Well, let's look at the numbers in front first. Is there a number that we can divide 9 and 3 by that's bigger than 1? 3, right? We can divide both these numbers by 3. So for our GCF, 3 is going to be in there, okay? Because we can divide both of these numbers by 3. Now, that's a good start. But greatest common factor, GCF, can have a number part and a letter part. Are there any letters we can pull out of both of these terms? Both of them have a q, right? This one has 2 q's. It's got a q squared. But we can pull a single q out of both of these terms. So it turns out our GCF for this example is 3q. So we're going to factor out this GCF this way. So to get the answer for this, we're going to write the GCF first. All right? We figured out what these terms have in common and we pull it out front. Next to this, in parentheses, we're going to write what we get when we take each of these two terms divided by the GCF that we took out. So, first we want to do 3q squared divided by 3q. Three q squared over 3q. 3 divided by 3, that cancels out. Q squared divided by q just gives us q. Right? Because we can think of this as q to the first power. And if these are being divided, we subtract the exponents. 2 minus 1 is a power of 1 that we usually don't write. This is just q. So q is the first thing we put in there. Different people teach this different ways, but we've got a minus sign here. That's going to stick around. So I'm going to go ahead and put the minus sign in here. That way, all we have to do now is 9q divided by 3q. That's bad q. There we go. 9q divided by 3q. Once we figure out what this is, that answer is going to go right in there and finish us up. So 9q over 3q, 9 divided by 3 is 3. Q divided by q, those q's are going to cancel out. So that's just 3. That 3 goes there. Booyah. It's been factored. There's nothing else we can do with that. So, the first step is always to look for a GCF, and that's the biggest thing you can pull out of both terms, or all the terms you have. All right? You can have a number part, and you can have a letter part. There won't always be a GCF, but if you always look for it first, you'll never get into trouble. All right. So, let's move on to example 2 here. Example 2. We need to factor this now. Now, if you're feeling daring, you can go ahead and try this on your own. You can pause the video, see how far you get, come back when you're ready. If you want to see another one, let's go. We want to factor this. Step 1 is always to look for a greatest common factor. So I'm going to put that here. Is there anything we can pull out of both of these terms? Can we divide 8 and 2 by any number bigger than 1? We can divide both by 2. Our first term has x to the 5th. This is x to the 3rd power. So you can think of this as 5 x's multiplied together here. And this is 3 x's multiplied together. So how many x's can we take out of both terms? How many do they have in common? 3. So we can take out x to the 3rd power from both of these. So our GCF is 2x cubed. So we'll put that out front. And now it's time to figure out what goes in here. And again, to do that, we take the first term here, 8x to the 5th, divided by our GCF. Eight divided by 2 is 4. X to the 5th divided by x to the 3rd. We subtract these exponents. 5 minus 3 gives us x to the 2nd power. So 4x squared goes there. Plus, go ahead and put that in there. Now we're doing 2x to the 3rd divided by 2x to the 3rd. That's all going to cancel out, isn't it? 2 divided by 2 is 1. X to the 3rd divided by x to the 3rd, that all cancels out too. So this is equal to, some people will say 0 there, but if we've got the same thing on the top and the bottom, that actually equals 1. right? Like 6 over 6 is 1. If you have a fraction with the same thing on top and bottom, that's 1, not 0. If you thought that, don't worry. I've had that a lot. I've seen that so many times in my years of teaching. You are not alone. But it helps to know that that's 1. So we've got 2x to the third times 4x squared plus 1. And again, that's all we can do there. It turns out, unless you've got something very special, if you have a binomial, which is something with just 2 terms, generally all you can do is try and pull out a GCF and then you'll be done. There are special cases, and we'll talk about those much later in the course, but for now, if you've got just 2 terms, take a look and see if there's a GCF. If so, pull it out front and divide everything by that GCF, and you'll be good. All right. So that's how to deal with binomials, 2 terms. A little later in the notes here, we see if we've got trinomials, which would be something with 3 terms. Okay, so as you're writing these notes, we're down a little bit further now. Trinomials are polynomials with 3 terms. And I say that there's a leading coefficient of 1. The leading coefficient is going to be the number at the very beginning. So if we go ahead and look at this polynomial here, we see that it has 1, 2, 3 terms. And the leading coefficient, the number at the very beginning, there actually isn't 1. That means it's a 1. That means it's a 1. Okay? So if we've got 3 terms, and there really isn't a number in the front, we see the same thing here on this example, then after we look for the GCF, that's still step 1. Step 2 is to do this. And we'll talk about that as we get to step 2 with this example. But I want you to know, before we start this example here, when do you know you're done? Okay? Here, this is all we could do. But with trinomials like these, you're going to be done when your answer looks something like this. You're going to have 2 sets of parentheses. And once you're done with it, once you have this, you are done. If you're asked to factor, which is what we're doing now. Okay. If you're asked to solve, you'll still have more work after that, but we're not doing that yet. So, let's take a look at example 3. We want to factor v squared plus 6v plus 8. Our first step is to look for a GCF. Is there anything, either a number or a letter or anything, that we can pull out from all 3 terms? Is there a number bigger than 1 that we can pull out from all 3 terms? Well, not in this case, right? If it were just these 2, we could pull out like a 2. But since the number in front of this term is a 1, there's nothing we can pull out. I know there's a 2 here, but the number has to be in front for us to make it work with the 6 and the 8. Okay. So there's no number. Can we pull out a letter from all 3 terms? Again, no, we can't, because this last term doesn't have a v in it. So it turns out there's not a GCF here. I mean, it's really the number 1, but it's not going to mean that we do anything different. So there is no GCF here, but that's okay. All that means is we can go to step 2 now. And step 2 is to find 2 numbers that multiply to the constant. And the constant is the number by itself at the end. So we need to find 2 numbers that multiply to the number at the end, which is 8. So we need 2 numbers that multiply to positive 8, and those 2 numbers need to add to the middle number. So that's the number in the middle term. And add to positive 6. So we need to find 2 numbers that multiply to 8 and add to 6. Now, I'm not super familiar with using an X to do this, but I've seen students in the past do this. That might be something that some of our Algebra 1 teachers do. And I think that maybe they put 8 here and 6 here, or maybe it's backwards. But that is what we're talking about doing here, however that works. I really should learn so I can help you out with that. But I usually just write it out like this. Two numbers that multiply to 8 and add to 6. See if you can find those numbers. Can you think of them? If you're having trouble finding those numbers, because sometimes, depending on what these are, it can be kind of tricky, what I always do, I write out all the numbers, all the pairs of numbers I know that multiply to 8. So I've got 1 and 8, 2 and 4, and that's it, really. And I look which pair of numbers adds to 6. 2 and 4. Perfect. So I know my numbers are 2 and 4, which is going to help me a lot. Once you found your two numbers, here's what you do. You're going to write two empty sets of parentheses that you're going to fill in. Your two numbers are going to be what goes in the back of each parentheses. So this is a positive 2, so I'm going to write plus 2 in the back of that one. This is a positive 4, so I'll write plus 4 in the back of that one. All that's left is to put what goes in front, and what goes in front is the letter that the problem is about. This is about V, so V goes in the front. So we've got V plus 2 and V plus 4. And hey, look at that. You're finished when your answer looks something like this. Two sets of parentheses. That's what we have. Amazing. So if you want to write like an arrow or a couple arrows to tell you where these numbers came from, okay, those were the two numbers that multiplied to 8 and added to 6. Okay. Now, what have we actually done here? Well, we've actually foiled in reverse. Remember foiling? We would do like V times V, V times 4, 2 times V, and 2 times 4. If you were to foil this back out, guess what? You get this. So now we know how to go in both directions, which is pretty cool. Especially when we get later on in the course, we're going to have problems where just one part of the problem might be factoring this or foiling this. So we want you to get really good at doing both of those things so that later on we can build on that and have you do more impressive stuff. So that's how we factor a trinomial with a lead coefficient of 1. We just got one more example in this video today. Just one more. We want to factor this. C squared minus 2c minus 15. You know step 1 is to look for a GCF. That's how we're going to start this one. Once you've done that, you know we're going to be looking for two numbers that multiply to the number at the end and add to the number in the middle. If you want to give this a shot on your own, I encourage you to do that. You can go ahead and pause the video, try it out, see how far you get. Maybe you get all the way to the answer, and unpause when you're ready. If you want to see this example worked out, follow me. All right, first step, find a GCF. It may have one, it may not. But either way, we have to look for one. Is there a number we can pull out of everything? No, because again, this leading coefficient is 1. That means you're not going to be able to pull a number out. Can we pull out a letter? Again, no, because this last term has no C. So again, there's no GCF here. But we looked. We tried to find one, and that's what matters. If there's no GCF, we don't have to pull anything out front like we did for these. We can just go straight into finding two numbers that multiply to the number at the end and add to the number in the middle. So our numbers have to multiply this time to negative 15. Okay, if there's a negative sign, it goes with the number after it. So our two numbers have to multiply to negative 15 and add to the middle number, negative 2. Negative 2. My cat is so annoying. What is your deal? Hi. Hello. Do you want to make a cameo? This is Bella. She's annoying, but she's cute. Hello, Bella. Now go away and be quiet. I know, you're right next to the microphone. You're going to deafen them. Okay, so we look for two numbers that multiply to negative 15 and add to negative 2. Maybe you were trying to find those as I was wrangling my cat. Okay, so again, if you can't come up with those numbers right away, that's fine. If you can, great. But if not, numbers that multiply to 15. I know they have to multiply to negative 15. We'll deal with the negative part in a second. Numbers that multiply to 15, 1 and 15, 3 and 5, and I think that's it. I don't think any others work. So we need our numbers to add to negative 2, but they multiply to negative 15, which means one of these two numbers has to be negative, and we need them to add to negative 2. So what numbers are going to be able to add to negative 2? 1 and 15 aren't going to get us there. They're too far apart. So we're definitely going to be using 3 and 5, but which of them is negative? If they add to negative 2, the 5 has to be the negative number, right? You could guess. If you guess that 3 is the negative number, do 5 minus 3, that would give you positive 2. To get negative 2, the 5 is the negative 1. So we've got our two numbers. We're so close. We can now write our parentheses here. The two numbers we have. Shush. The two numbers we have go in the back of our parentheses here. We have a positive 3 and a negative 5. So since this is negative, we'll put minus 5. Okay. Those are our two numbers. And in front, same as the last problem, the front goes the letter. This is about C. So we put C in front. I know we usually use the letter X in algebra, and if you put X's in here, I wouldn't be super upset about that. I would probably still consider it right if you did everything else right, but try to keep your eye on what letter is being used in the problem so you can use that one. But here we have C plus 3 times C minus 5, and we have factored that polynomial. So, in this video, inside 25 minutes, you've possibly relearned completely how to factor. We took some binomials and took out a GCF. We took trinomials and found out what to put in these parentheses. So, we are still going to be in this section completing our notes in the next video, and then you'll have some problems to work on your own. So, I hope we're off to a good start here. If you have questions, again, 11 to 1 every day, I have office hours, and you can ask me any questions you have. I also have virtual office hours, Monday from 10 to 11, and Wednesday from 1 to 2. You can join my Zoom meetings at those times and talk with me live, if that's what you want to do. I love talking to my students, so feel free to drop by if you're available then. Otherwise, have a great day, and we'll see you next time. You're so loud, cat. So loud.